So I think we have everybody here. So hi, everybody. Welcome to the webinar. This is being brought to you from Diagrid. We're talking about Dapr, and Diagrid is really the home of Dapr. We were founded by the folks that created Dapr at Microsoft. And if you want to check out the offerings and a lot of the content we have on Dapr, in addition to Bilgin's blogs, you can find us at diagrid.io. So I'm very honored and pleased to introduce my friend and colleague, Bilgin Ibryam. Bilgin is a very well-known speaker, presenter, writer. He's also the co-author of the Kubernetes Patterns book with O'Reilly. So check that out, although I'm sure a bunch of you have already covered that. And without further ado, I'll hand over to Bilgin to talk to us today about Dapr as the ultimate microservices patterns framework. And I'll be back at the end. We'll have Q&A. If you have any questions, please hit up that Q&A button on the Zoom control bar, and you can type them in there, and we'll answer them by typing as we go, and we'll kind of round them up at the end. So enough from me. Over to you, Bilgin.
Thanks, John. Can you hear me well? By the way, can you see the slides? You were a little bit breaking up, John, so I'm not sure if it's happening on my side or it's yours.
I'm sorry about that. You sound great.
And you can see the slides?
I can see the slides, yeah.
All right. Good morning, good afternoon, good evening, everybody, from where you're joining, and thank you for being here. Now, the topic of this webinar is how Dapr helps implement microservices patterns, right? We will explore Dapr's unique capabilities and why it's a great choice for creating distributed applications. I won't go over the introduction. John did that. I will only add one thing, actually. So if you are interested in Kubernetes and Kubernetes patterns, you can go to the link there and grab a free or paid copy of the books. And if you are coming to KubeCon Europe, I'll have a talk where I will look into how Kubernetes patterns have been evolving over the last 10 years since Kubernetes was created. So if you're at KubeCon, join me there. So in this talk, we'll cover, design patterns. We'll look at the microservices patterns, enterprise integration patterns, workflow patterns, and how Dapr APIs fit there and how you can deploy Dapr. That's the agenda. So what are design patterns, right? And what are they useful for? The concept of design patterns actually dates quite back. So I think it's back to 1970, according to my understanding. And it is from the field of architecture, not software architecture, but proper architecture. Christopher Alexander and his team actually have written a book called Pattern Language. And this book describes patterns for creating, towns and buildings and other construction units. And the two patterns you see on the screen are, the first one is about designing cities, and it suggests making sure that the country fingers are at least 1 mile wide, and the city fingers should be at most 1 mile wide, for whatever reason. The second pattern here is called a beer hall, and it describes how public drinking halls should be constructed to make sure that, strangers and friends drink together and not in lonely corners. Something that was thought as a good pattern was become an anti-pattern 2 years ago, right? Moving forward, if we fast forward a few decades, we can see the concept of pattern applied to software too. The most popular example here is Design Patterns by Gang of Four from 1994, where the authors talk about designing object-oriented systems using primitives such as classes, interfaces, methods, etc. A decade later, 2004, the other seminal book, Enterprise Integration Patterns by Gregor Hoppe and Bobby Wolf, and it describes, standardized way for integrating applications, focusing on messaging systems and how to connect various services. So these are all patterns. Examples, from a specific domain, such as object-oriented programming and integration. Moving forward, a decade later, right, we can see examples from specific technologies such as Java and Kubernetes. In case of Java, it's about using the JVM language, the Java language, and the JVM workings to create good applications. And in the case of Kubernetes, it's about using Kubernetes primitives such as containers, pods, services, etc., and combining them in a way to get to desired outcome. In essence, we can say a design pattern is a general repeatable solution to commonly occurring problem within a specific context. It's different from a recipe because it doesn't give step-by-step instructions to solve a problem, but it kind of provides a blueprint for solving a whole class of similar problems. And good thing about patterns is that they encapsulate, they capture expert knowledge and design trade-offs and make that widely accessible through simple language and vocabulary, right? Patterns can be from different granularity, they can be very low level, for example, this singleton pattern in object-oriented design, or it can be much higher level, like the gather pattern in enterprise integration pattern involving, producer, consumer, message broker, lots of messages, etc. And I think, to close up here, the language aspect of patterns is becoming much more important. It helps us to navigate a large problem space and quickly, communicate with each other more efficiently, and probably, help us communicate with machines such as ChatGPT more efficiently in the future. Now, let's talk about microservices and patterns. Like microservices, as you know, it's an architectural style for structuring applications as a collection of independent and loosely coupled services centered around specific business capability. Now, this allows each service to be independently deployed and managed by a dedicated team. And if you're embracing microservices, you get many benefits. For example, you would rapidly and reliably deliver complex applications and meet the demands of changing business. But while although microservices offer these many benefits, it has challenges. For example, microservices use different inter-service communication styles that require expertise in a specific technology. Each microservice maintains its own database, which makes data consistency across services harder. Network resiliency becomes a vital part as services are distributed and rely on the network, right? There is an increased attack surface requiring things such as zero trust architecture. And there is basically a diversity of technologies, all leading to technology sprawl. And I think the good news is that microservices are not new. They've been here over a decade now, and most of the common technical challenges, not so much organizational process, but the technical ones are understood and the solutions are documented. A great example for this is Chris Richardson microservices pattern book, which I have, and his website, microservices.io, where I did borrow a few of the diagrams today. And this website has a list of patterns, in a format such as a context, a problem, a solution, and related patterns that can be an alternative solution with a slightly different context and with slightly different forces. Right. That's all good, but there is a catch. And the catch is that these patterns are only the theory, right? You need to they will help you to do the trade-off analysis. There is a visual notion to understand, there is language, but you still need to implement these patterns to address the problems. And while these patterns give you the theoretical guidance, right, the implementation where the real challenge is. And this is where Dapr comes. Dapr provides concrete implementation of these patterns, and it kind of bridges the gap between the theory and the practice, right? It's not just about understanding the patterns, but also applying them efficiently. And as the patterns are actually intended to be reusable and repeatable and be able to apply across a wide domain of problem, Dapr architecture makes that possible by allowing it to be applied across different languages, runtimes, clouds, etc. So in essence, let's say Dapr helps you avoid re-implementing the patterns in every language, in every library. So what is Dapr? No, very quickly. Dapr, which is short for distributed application runtime, it's an open source framework. It's designed to ease the development of distributed applications, and it does that by providing a set of APIs, which in the Dapr world are called building blocks. That these APIs enable applications to communicate with each other. Here I have 3 applications, ABC, and allow these applications to communicate by backing infrastructures such as various, message brokers, state stores, and other services. And this way, Dapr helps developers focus on the business logic and unique features of their application rather than dealing with the complexity of service communication and cross-cutting concerns. And Dapr architecture, it uses the sidecar pattern, that's our first pattern, where each microservice is paired with Dapr runtime that provides the API. And this API, see them listed here, do things such as state management, messaging, synchronous call, workflows, etc. And what makes Dapr unique is that thanks to the sidecar architecture, it makes these capabilities available to all language, and its ability to abstract the underlying infrastructure, which gives the portability across different platforms, right? And this flexibility makes Dapr appealing on all clouds and runtimes and languages. So let's see an example of an application and start exploring what are the problems here. So here we have a distributed application with a range of interconnected services, right? From user-facing front-end to back-end, like the shopping cart, the inventory, the notification system. And these services communicate in different ways using, request reply, orchestration, publish, subscribe, etc. And we'll use this scenario to guide us through various patterns, right? One of the first challenges in such a architecture is the initial setup of the services. It often involves repetitive tasks like configuring the build logic, addressing the cross-cutting concerns such as security, observability. And these tasks can be time-consuming, especially in large environments where you frequently create new services. And this requires a streamlined approach for creating new services, which leads us to the first pattern, the service template pattern. So the service template achieves efficiency by providing a pre-built template that already includes the necessary artifacts and configurations to bootstrap and build a new service. So using such a service, service template leads to consistent and rapid setup of new services. And it covers the areas such as, code repository structure, the build configuration, how you're going to do containerization, etc. So the whole idea is part of your golden path in your organization or the paved road. If you use some platform engineering terminology here, there is a standardized way to create a new microservice and doing it quickly. What does that mean for Dapr? Assuming you have Dapr in your environment and let's say you're using Kubernetes to deploy, incorporating Dapr into a new microservice using the service template is straightforward. You just have to annotate your Kubernetes deployment, the application deployments, to ensure that the sidecar is injected. So really, the template is typically a simple runnable service that makes with some kind of a sample application logic. So you could add, for example, Dapr SDK for that language of choice and provide a sample, publisher consumer code too. And that's the job done with this pattern. Now, the service template actually has, say, like 3 main drawbacks. First is that it's a form of copy-paste programming. If you change the service template because you want to improve it, you have to update the service instances manually and vice versa, right? And it's language specific and requires a template for every language. If you are, if you are not using Dapr, you need to add libraries for all cross-cutting concerns. And the problem is that it's trying to address cross-cutting concerns, which requires many libraries. So in summary, I would say the service template is effective for establishing a project structure and build process, and aligning with the concept of platform engineering golden paths. However, it's less ideal for addressing cross-cutting concerns like service interaction, infrastructure interaction, security, which is more context-aware and requires a more dynamic approach. And that we'll explore in service chassis. So what's the service chassis? Here, the idea is that you address the limitations of the service template by, rather than copy pasting into every service the libraries you want, the dependencies for handling cross-cutting concerns, you use a framework. And the framework does things such as, configuration, logging, service discovery. And you plug your application into that framework, and that's the job done. So basically moving from template with lots of libraries, you move to a framework that provides these capabilities. And here are, I would say, like 3 different ways to implement service chassis. The library approach we've seen is actually used primarily in service template, and it integrates various libraries into your application, but that typically leads to plumbing drift. Once a new service is created, it loses the connection to the template, and any future improvements in the template don't propagate to the service. The next one is the platform approach, like Kubernetes. You might be saying, I'm using Kubernetes, that's my service chassis. While that's great, Kubernetes is good for keeping your containers running, but it doesn't extend to managing things such as inter-service communication, application level, cross-cutting concerns we are talking about here. So it doesn't address all these concerns. And the approach that's used most with service chassis is the framework, which involves embedding your application into framework like a Spring Boot, GoKit, and Gizmo, etc. And the framework not only manages the cross-cutting concerns, but it also ends up controlling the flow of the application. So your application can call the framework, but the framework can call also your application too. And the downside of this is that it's language specific. So your application actually has to be in the language of the framework and the dependencies it uses. So how is Dapr differs here? So Dapr is also kind of a framework, right? But it operates differently. Unlike traditional frameworks that run your application, Dapr runs alongside it, acting as a sidecar. This setup basically gives you the freedom to choose the best language you want and the best runtime you want for your services, and still address all cross-cutting concerns consistently, regardless of the underlying backing service or the language. On the table here, actually, you can see, I've been mentioning cross-cutting concerns. You can see actually a list of example cross-cutting concerns that are typical for microservices, and a short list for each of those that implement these cross-cutting concerns. Now, while Dapr is not a one-to-one replacement for each of these projects, it has a pretty good coverage in most of these areas. And it also, leaves the runtime choice up to you. To sum up, service template and the chassis are typically complementary. The service template is ideal for build and pipeline configuration, and the chassis is ideal for addressing cross-cutting concerns. And there you have the choice to use something like a Dapr or combine multiple other projects for the same purpose. All right, so returning to our overview of microservices, now we know how to create new services quickly. Now let's focus on service interactions. Every service needs to talk to other services, right? And despite the rise of asynchronous methods, synchronous calls remain widely used in microservices. And these synchronous interactions, they bring additional considerations. For example, we need service discovery for locating services. We need resiliency strategies to handle intermittent failures, observability for monitoring these interactions, and access control, and so forth. And here again, you might be saying, okay, I'm using Kubernetes, and Kubernetes has the service object, right? And actually, that object has 6, 7 different types of services you can create with it. But if we start looking into those service types, you'll see that half of those are actually for getting traffic external traffic into the cluster, such as node port, load balancer, ingress. Some of the others are for getting traffic out of the cluster, and the one that's used for internal service discovery doesn't have things such as resiliency, circuit breakers and retries and timeout. It doesn't have tracing capabilities, ability to encrypt traffic, and service discovery is limited to its only within the cluster, right? And this is where Dapr service invocation API comes into play. These are two of the services from our sample app, right? And here I have the checkout service, which is running on localhost 5100, and a customer service that wants to call the checkout and its order method. And by not calling it directly, if it instead goes through the Dapr sidecar and the service invocation API, so it would call port 3500 and the invoke API. This is what will happen and what benefits you'll get. First thing is you'll get the location transparency. That's basically service discovery, right? Which, if deployed on Kubernetes, in that case, if Dapr is deployed on Kubernetes, it will use Kubernetes service discovery, but you can plug in there something else like HashiCorp console. You'll get traffic encryption between the sidecars, MTLMS. You can extend that with token-based authentication between the app and sidecar, right? So you have the option to use access control and apply authorization rules. So you can say which service can call which other service on what protocol and what operation, things like that. You get all the resiliency and observability on the networking layer, and all that from a single Dapr API. So if I map those, by using Dapr service invocation API, what patterns are we getting from the list of patterns in microservices.io? Remote procedure invocation. That's basically the server. That basically Dapr actually converts that into a polyglot standardized API for invoking other methods, right? So there is improvement. Service discovery. The Dapr service discovery is interesting. So it's kind of a combination, a hybrid between client and a server. It is a client-based because every application has its own sidecar, but that sidecar almost acts as a server, so it's not embedded within your application, right? So you get service discovery, you get health check. So in addition to Kubernetes health check, Dapr can also perform health check, and it will impact how Dapr interacts with your application. The difference here is a Kubernetes health check primarily impacts, it restarts your application, it directs incoming traffic. With the Dapr one, it can also impact, how Dapr talks to your application when reaching out to external endpoints. You get distributed tracing, metrics, and logging specifically on the networking side. So quite a lot of patterns covered here. So let's continue, right? Back to our microservices overview. And not all services communicate synchronously, right? Asynchronous event-driven interactions offer multiple benefits, such as, you get temporal decoupling between the services where the producer and the consumer can, scale independently. You get decoupling of their lifecycle. You can bring one down and the other one won't be impacted. You get load shedding. There is spike in the number of messages that will be handled by the broker and it won't affect the consumer, and so forth. So let's look at Dapr publish subscribe. If you look at Kubernetes, there is nothing that can offer this kind of capabilities. You will need something like Knative on top. Again, here are two of the services from the overview. And in this case, the shipping service is listening on localhost 5100. This service, if it wants to receive messages from the broker, it needs a subscription, which can be done declaratively. So you can apply a YAML file and subscribe this application and this endpoint to a specific topic, or it can be done programmatically. So your application actually can expose a REST API, REST endpoint to describe where it wants to be subscribed, and the sidecar will do that. And the checkout service, in this case, publishes messages to the my broker order messages topic using Dapr. And what happens, behind the scene? What do you get? The first thing you'll get is broker transparency. So a Dapr PubSub API offers a high-level messaging API that's kind of independent from the underlying specific message broker. The other thing you get is a cloud event envelope across all messages. So you get the standard set of headers that you could use later for routing. You get the encryption again with MTLS and token authentication, but you also have the ability to additionally encrypt the messages if you want on the sidecar. All the resiliency policies we see with the synchronous interactions, they also apply here. So you can have retry, circuit breaking, timeout, even with PubSub, and all the observability. Now, also what you get here is that Dapr PubSub API is actually, its purpose is not just to abstract the broker, but offer capabilities independent of the broker. So these might be capabilities that are available or might not be available in the underlying broker. These are things such as TTL and DLQ and bulk messaging. So even if the underlying broker doesn't support, for example, message expiration, Dapr can make sure that a message that's expired never reaches the consumer and it goes to DLQ instead. If the message broker doesn't support DLQs, Dapr can do that. If that messaging system doesn't support, aggregating and splitting, with bulk messaging, you can do that to reach better throughput. So if I map those capabilities to patterns in this case, in this case, I'm not using microservices.io patterns, but I'm using enterprise integration patterns from Gregor's book. And as this list provides a more extensive list of patterns from messaging point of view. So what are some of the patterns? Message expiration is actually achieved with the time to leave property. Dead letter channel are the DLQs. Guaranteed delivery, Dapr can do that by using a message broker with a persistent store and using at least one delivery guarantees. Content-based router basically allows you to route messages to different service paths. And with Dapr, you can use a common expression language to route or filter messages to different paths. Aggregated splitter pattern, that's achieved through bulk messaging, where Dapr sidecar can split the messages or aggregate them before interacting with the broker. Service activation messaging gateways are Dapr's API abstracting the message broker. So you can see that it kind of hits a lot of checkboxes on this aspect as well. So moving on, going back to our microservices challenges. What about if the shopping cart service requires, a stateful, persistent orchestration of inventory and payment service interaction using with something like the Saga pattern? Maybe the shopping cart needs to reserve inventory, then authorize a payment, and if that's successful, reduce the inventory, otherwise release the inventory. And you also send a message to the shipping service, right? So that requires a stateful, persistent orchestration of steps. And that can be achieved with Dapr Workflow API. So in a nutshell, Dapr Workflow is a programming model, and it's also an API that makes it easy for developers to write stateful business logic in a reliable way, right? The workflows are stateful, and they support long-running and fault-tolerant interactions. And these workflow definitions actually do integrate with the other Dapr building blocks, such as service invocation, PubSub, state management, bindings, and the other APIs. In this example here, what I have is a workflow definition where, the first step, the first task is activity A that calls the secret API to retrieve a secret. And in the next step is actually waiting for an external trigger to happen. When that's done, the workflow definition defines two activities, activity B and C, which are basically executed in parallel, doing completely different things, like a service invocation with the invocation API or accessing to state store. Then these parallel activities are again merged into one in activity D that publishes a message which goes to the end. This is an example workflow, and actually in the workflow domain, there are long list of workflow patterns. Here, I picked 4 popular workflow patterns, from a much longer list. And if you want to see these workflows, how they are implemented in Dapr, my colleague has provided a sample code and a blog post in .NET. You can see the link there. And these patterns basically are, sequence, external trigger, split, synchronized timer. So if we go quickly through, the sequence is basically it says that a task in the process is only enabled after the completion of the previous one in the same process. So in that case, I have 3 tasks, activity A, B, C, and they are executed sequentially only when the previous one is completed. External trigger, another workflow pattern, well-known one, and the idea is that the task is triggered only by a signal from another part of the process, but more commonly from an external environment. So that can be a long-running business process that stops at some point and requires, a human interaction. Somebody has to do something and approve, for example, a payment in order for the process to continue. Split and synchronize, that's actually a combination of 2 patterns. Split basically is a divergence into 2 or more parallel branches where each execute completely independently and concurrently, right? And synchronize is the opposite. It's the convergence of 2 or more branches into single one where the control is paused until all branches have completed. It is similar to scatter gather in the messaging world. And the last one is timer, which is basically gives you the ability to wait until a specific time or a trigger an event at a specific time. So these are examples of workflow patterns that you can easily implement using the Dapr workflow API. So there is a common question, that keeps coming in this space, and that is, considering whether to use choreography or orchestration in microservices. And we often face, this challenge. And I think, some of the motivation is let's use choreography for scalability and boost completing, and use orchestration to get a better control and visibility in the state of the business, in the status of a business process. But this choice frequently is influenced by the available tools. So whether you have, a message broker such as Apache Kafka and you have lots of expertise around that, or whether you're using a workflow engine and that influences and drives many of the decisions which one to use. And I think that's the wrong question to ask. So typically you would need both approaches. So workflow are, effective for managing interactions and steps within a single microservice, while choreography is good for coordinating interactions across microservices that are loosely coupled. And with Dapr, you have the flexibility to choose based on your needs and not what tools you have. And the good thing is that the unified programming model with Dapr, helps developers to implement these both approaches in a single service. So very often in a service, you would have orchestration, some kind of business logic, and as we seen earlier, some of the steps would also publish messages that's basically choreography. And using Dapr, you have a single programming model which has a unified way of handling errors, and you get single unified observability on top of that. And that's super useful for operational, which have to manage this system. So rather than trying to debug what's the state of an application, whether in order to check different systems like a message broker and workflow engine, you get a unified view from operational point of view as well with Dapr. All right, so let's look at the time, and we are almost at the finish line. There's a few more. So back to this view of microservices and the challenges. There are still many other challenges. This was a quick run, but with microservices, you may have certain challenges that apply, case by case, and they're not so common. For example, when you're writing to a state store, you might want to encrypt the data because the state store might not support that, or it can be a message broker such as Apache Kafka, so that's a common requirement there. Or when you're writing to state store like a database, you may want to emit changes for every state change, right? That's the transactional outbox pattern. That's becoming more common way to do dual writes these days. Or you might want to implement the singleton pattern, right? Maybe you are consuming from a message broker and you want to consume sequentially. You want to have only a single instance of that consumer, or you are consuming from a file system. You don't want a service to be accidentally scaled, right? Or even if it's scaled for high availability reasons, you still want it to be a singleton or have a control over how many instances it can have. And you basically need a distributed log. So all these are examples of various other needs and patterns. And Dapr offers this kind of capabilities through its other APIs. Now, I won't have time to go over this. I'll just list those. Like transactional outbox pattern is actually a capability of the state API. So when you are writing to a state store with a single configuration change, you can make Dapr also transactionally emit changes to a message broker that carries the state change. The binding APIs allows a bidirectional connectivity to third-party systems such as Twilio. That's basically the connector pattern, right? Distributed log API, the one I just talk about, it gives you exclusive access to resources. That's the singleton pattern implemented at the application level. Configuration API allows you to for your application to be configured, so you can edit configurations. But not only that, if the configuration change, Dapr can push that into your application, so you can get dynamic configuration changes if your application is can make a use of that. Secret APIs for working with secrets, right? And the crypto API is not about cryptocurrencies, but about encrypting and decrypting your messages before processing them, right? These are the other Dapr APIs. And finally, I want to close, with the different Dapr deployment models. Okay, I see a typo in Dapr name. So what we said so far is that Dapr runs as a sidecar on Kubernetes, but that's actually not all. Dapr can run easily on VMs where you don't have Kubernetes, or you don't have even containers. So that can be some kind of edge deployment. The main challenge there is that you are responsible for taking care of and managing the control plane elements. Right, the more common way to deploy Dapr is on Kubernetes, where the control plane comes in the form of Kubernetes control plane and operator. And on Kubernetes, the data plane, the sidecars can be used in different ways. The most common one is every sidecar is injected into every application pod, right? Whether that's through deployment and stateful set, and this gives the best isolation both from resource isolation and security point of view between the different application instances. That's what you have on the diagram here in the middle. But actually, there is another way to run the Dapr sidecars, and that's the shared sidecar model, where you can have multiple instances of the same pod talking to one instance of the Dapr sidecar, which runs as a daemon set or a deployment. And that can be more interesting when you can trade off, some of those security and isolation to save cost, or you want to use that from some highly rapidly scaling functions, and you want Dapr sidecars to be shared. That can be an option. You can use it from short-lived jobs, etc. The main challenge when you are running Dapr on Kubernetes is you still need to perform some operational tasks, like you need to upgrade the Dapr control plane, the sidecar, you need to rotate certificates, etc. And that's what we are doing with Diagrid Conductor product, which is a managed control plane for Dapr on Kubernetes. It basically allows you to do all the operational tasks of maintaining Dapr on Kubernetes. It offers you a list of checks whether you follow all the best practices on configurations for production, whether you have the optimal resource tuning, if you have any issues with the control plane, data plane, the underlying infrastructure that affects these applications. It can, raise alerts and tell you what's wrong. That's Conductor and Dapr on control on Kubernetes. Now, moving forward, we can see that Dapr can be actually further decoupled from your application. And there is actually a way to use Dapr outside of Kubernetes on a cloud environment. For example, if you are using some kind of a container service or a serverless function, you can call Dapr APIs directly. And that's what we have, why we have developed Diagrid Catalyst. It offers Dapr as a serverless APIs. And in that case, you don't have to manage not only the control plane, but there is also no data plane, no sidecars for you, only Dapr APIs, which you can use using the SDKs or HTTP. So check those links out. I think this shows how Dapr is becoming more of an API and a toolkit, that the deployment model is more of an operational concern. From development point of view, you have all these patterns available through the APIs. So last slide, the closing thoughts. I'd say developing the distributed systems is hard, right? Full stop. And the patterns kind of offer a structured way to understand, navigate, communicate within this complex and vast problem space. And it gives you, proven solutions and best practices. And Dapr is, in my view, is the ultimate toolkit that helps you implement these patterns, and it offers adaptability, across multiple platforms such as Kubernetes, serverless. It also helps you really to avoid re-implementing these patterns in every language and library. Here are a few links. So if you are running Dapr on Kubernetes, check out the Conductor link. We have access for a free trial. If you are interested into using Dapr without managing control plane, the sidecars directly from a serverless environment, check out the Catalyst product and the links if you want to hit me on Twitter with some questions. John, back to you.
Thanks, Bilgin. Wow. That was quite the whistle-stop tour through Dapr and then patterns. And I have a couple of my colleagues. We have Kendall, we have Mark and Alice, who may want to turn their cameras on. They've been answering some questions while we've been talking through this. So, well, we can go through some of those, but folks, we have about 15 minutes. So if there are other questions arising from this, or, this is, Bilgin's here, he's written on a lot of different topics. So if you have any just questions generally about things he's written about, it's fair game to ask those now. Alice and Kendall, do you want to tell us what's been going on in the Q&A chat?
Yeah, for sure. There's been some good questions. Yeah, there's been some good questions in the chat. The one I wanted to call out that was recently just posted by Mike. And Bilgin, maybe we want to actually bring up the slides again just for this really quickly. He mentioned if you have, such loose coupling like in your checkout service, how would the application know the status of, say, checkout if a service called a service, etc., and what happens if it fails after calling two services? Kind of an interesting microservices patterns question there. I figured just the slide that had the services on it. Yeah, exactly.
Yes.
I think Bilgin, this was in the context, if I'm not mistaken, of the workflow. So when you were talking, at least that I think it was, but.
Yeah. I have to read the question again. So if you have a loose coupling like checkout service, how would the application know the status of checkout?
Maybe.
Okay, so I'm not sure what exactly the question is, but it kind of reminds me of two patterns, I'll say that way. So one of the common patterns for solving this kind of problem is the saga pattern, right? And the idea there is that sometimes you may have to call multiple other services in a sequence. And like, for example, when you're booking holiday, you want to book the hotel service, you want to book the flight service. And if the second one fails based on the status of that, you can still call the first service and compensate on the actions to rectify what has done. So that's one way to deal with this kind of scenario. I'm not sure whether in this case the question might be raised because the checkout and shipping services are using message broker. It is also possible to do request reply over a message broker. So there are other patterns that can help you to do asynchronous request reply. So that can be used to communicate back the status of the call. I don't know if that answers or not.
I would say too, Bilgin, just to like supplement as well, like one thing that's really nice about Dapr workflows is it's a very good way of handling this case, right? If your checkout service is part of like a checkout process end to end, right? And the checkout service maybe calls, it would basically have an action, right? That wraps a particular part of that checkout workflow. If that action is to fail, whether it's because the resiliency policy, in the service invocation request failed, whatever that might be, right? It can propagate that error back to the orchestration instance. And the orchestration instance can basically say, based on the status that I got from this action, I want to take compensating, logic. So there's a really good example of this. There's a really good example of this essentially in the Diagrid Labs repo, where you can actually see what it looks like to have, for example, if you go through the checkout process and maybe the payment fails, right? How do we actually go back, or excuse me, there's no inventory left by the end of the checkout process. You can actually go back and do a compensating transaction to like refund someone's payment, right? So to me, I think that's another really good pattern that you could use for that case, is this like workflow API within Dapr. And it's important to call out too, the workflow API obviously integrates well with the other Dapr APIs that are provided. So you can use pub/sub, you can use state in the context of a workflow.
So, Mike, did that answer your question? You can unmute if you'd like to.
Yes, thank you. Sorry, just trying to find the mute button. Yeah, I think so. I mean, it's it looks like a great framework and lots of stuff in there. I'm just kind of trying to understand how you've got all this kind of loose coupling and services calling services, and where traditionally you would do something within a transaction, but as Kendall just said, where your payment fails and you've gone and already pulled that inventory and done whatever to any other parts of the database, how to sort of compensate for that, and how do you know what the status is of it if it's all sort of within the microservices sort of framework. But yeah, I think you're pointing me in the right direction.
Awesome. Thanks for the question. I'm going to go to Bala Saheb, who's been patiently waiting.
Hello, can you hear me?
We can hear you. Yes. Welcome.
Yeah. So I have a question actually about serverless execution. I am like in my company, I am trying to migrate to serverless. We have our application, and it's a microservice-based application. So right now, it's always on, like services are running always on. I'm trying to convert it into a serverless, but the problem I'm facing is that the cold startup time, right? So even though I worked hard and I reduced my application start time under 100 milliseconds or 1 second, still the pod startup time there is a pod startup time, right? So almost 2 to 3 seconds. My question is, with Dapr, how do do we face this kind of cold startup times if I plan to use Dapr for my serverless execution?
I think I can touch on this, Bilgin, unless you want to take it.
Yeah, go on.
Yeah, I was just going to say, so if you're running within a Kubernetes setup and you want to scale the Dapr sidecar along with your workload, you're going to have the same cold start, right? Because it's basically contingent on the pod. Sorry, I'm hearing a little bit of an echo. I'm going to mute really quick just until I finish. But yeah, so you will have the same startup time, like the cold startup time. Now, if you're using the serverless offering that we provide at Diagrid, which is currently in private beta, we don't have that because we're not scaling the sidecars all the way to 0. So you'll always have basically one warm instance in this case. So you can think of it that way, right? So whatever the cold start is on the application workload wouldn't impact or have any correlation to cold start on the sidecar. So as long as your application is up and available, depending on how you're running it on the Kubernetes cluster or whatever workload platform you're choosing to use as a host, you won't get a cold start time on the serverless sidecar that we're managing on your behalf. So
that's on serverless, but if the question is about on Kubernetes, so that's why the Dapr shared is created. So if you are doing serverless with Knative, for example, right, you can use Dapr shared model, which will make sure there is a sidecar that's running as a daemon set that's available if your functions with Knative scale rapidly, or when they bootstrap from 0 to 1, right? So that's another option on Kubernetes.
So I'm going to jump to Jose. Sorry, getting an echo. To Jose's question about scaling up, scaling down with respect to a service if Dapr is hosted as a sidecar. And how does that work for communication to another service? Alice, I think you've started answering this one.
Yeah, I just was answering that one. Yeah, good question. So in terms of the scaling up and scaling down on Kubernetes, this is just going to be kind of standard Kubernetes scaling in terms of pod. So you could use something like HPA or whatever pod scaling mechanisms that you use. We see lots of people using like Kata and Dapr together. If you haven't heard of Kata, it's like the Kubernetes event-driven autoscaler. And then in terms of the second part of your question, hosting or communication for another service, like I'm unsure exactly where you're getting at with this part, but it would just be, the number of replicas that you would have for the application container. They would each have a single sidecar as well as the application container within that pod, and then communication between each other would be handled, like again through the Dapr APIs for something like service notification, or asynchronously if you were using something like on PubSub. Does that answer your question, Jose?
I was interested more of this. Suppose service A get a lot of requests and I have a sidecar Dapr hosted to communicate to service B. Service A, I know that it can handle based on an HTTP request or some kind of a scaling mechanism I'm using. And with respect to service A, got five scaling mechanism or 5 pod running on a 5 pod. And when it's scale down, how the Dapr will work, because that each one I'm hosting on a separate pod, the cost will be there as well.
Okay, I think so. When Dapr scales down, or when the application itself will scale down, then so will its associated Dapr sidecar.
Yeah. Okay.
Sorry.
Thanks.
And then, okay, does that answer your question though?
Yeah. So I was, wondering whether it can have a detached property where I can handle my service, not bothered to Dapr services, how it's scaled down with respect to my service A, because service A talk to a sidecar of a Dapr service, then that Dapr service goes to another couple of other services. You know that.
I see.
So when I scale down one of my major services, that is a Dapr will automatically scale up, I believe so, and it will automatically scale down with my major service and my.
Dapr will scale because Dapr doesn't handle your application lifecycle, so you would need something like Knative, but because Dapr is a part of your application pod, so it will scale with the application, right? And if that application is scaled down and removed, right, it will be removed from the list of applications and sidecars. Actually, even if your application is not removed, even if it fails, Dapr performs health check on your application. So if it's not healthy and not responding, it will remove it from the list of healthy endpoints to call. So there are different mechanisms you can control that and make it fail gracefully, if that's what you want, right?
Yep, that's what I.
Wonderful. Well, we're nearly out of time. And so thank you everyone for your questions. I realize we didn't get to everything, but you can find Bilgin and the rest of us on Twitter and LinkedIn. And you can find Diagrid at Diagrid.io, one word. But thank you for joining, and we'd love you to join us again. So our next webinar is Dapr focused, and Mark is going to be presenting that. Mark, do you want to give us a quick trailer of what you'll be talking about?
Yeah, I don't have anything on screen, but just need like this. It will be talking about Dapr actors. So the title is Exploring Dapr Actors API in .NET. So I'll give many like code samples in .NET and have like an end-to-end demo. And we'll cover things like state management and actor-to-actor communication, timers, reminders. So yeah, I hope to see you there.
Yep. And so that will be on Wednesday, February the 15th, same time as this webinar. I won't try and do all the time zones. And you can register for that today if you go to diagrid.ws, as in like web service /webinars, and you can reserve your spot there. And with that, I think unless anyone else on the panel has anything, I'm going to say thank you. This has been fun. We're going to do this again. If you have particular topics you'd like to hear Bilgin talk about from his vast kind of library of blog posts, let us know, and we'll get that sorted out. But this has been the first, and it's been good fun. Good fun having the panel as well. So thank you, panelists. Thank you everyone that attended. This recording will be on our YouTube channel within the next 24 hours as well. And with that, I'll say thank you and goodbye. See you next time.